Welcome to the weekly Antelope Node Operators Roundtable. We're going to talk about the latest updates on the development of the Antelope Leap node software that powers EOS, WAX, Telos, and other Antelope blockchain networks. Every week, BPs and node operators come together here on this call to share the best practices gained from running Leap nodes in the wild. If you are watching this on YouTube, you can join live every Wednesday at 9 a.m. Eastern. You can find details to join the call in the Antelope Node Operators Roundtable Telegram group. Just ask your nearest Antelope node operator for a link to that if you're not aware how to join. Today is January 17th, 2024. And we have two topics that we are going to discuss. We recently released Leap 5.0 stable, and so node operators have been getting that installed, and we're going to discuss experiences with that so far. Also, we're going to discuss how we can make Node.EOS easier for non-block producers, less technical users, to be able to run nodes in the future. So some future-facing brainstorming. Let's get right into the very first topic. So it's been about 2 weeks, if my math is right, maybe 3, since 5.0 was released stable. And I know that some folks have been getting upgraded and running that in production on API nodes, block producer nodes, and other sorts of nodes. We've heard reports that it is less memory intensive and that it is able to sort of cram in more transactions in certain scenarios. But I wanted to open the floor here on this call to get reports from experiences that you've had upgrading to 5.0 and what you might have seen so far with it running in production. And so with that, let's do a quick sort of show of hands of folks that are here. And you know, if you're off camera, you could just pop something into chat. Let me know if you have upgraded to 5.0 or if you're planning to soon.
Kind of half-baked at the moment. Got a little bit of everything going on.
Okay.
Yeah, halfway through it. It's a lot.
Yeah. But I've also used it as an opportunity to rationalize all of our configurations.
Correct. That's what, and that seems to be what most other VPs have been doing too. We've all been kind of shooting them around, and
yeah,
I've been minimizing my configs because that's as much of a problem as opposed to updating configs like it's always been done throughout the years. Really, it's just been here's a new one. Turn on what you need to. Let's reset. Personally, Ross, I know some other ones are saying, no, my configs aren't in Git. They are on a central repo in my own network, but no, we're not EOS nations. Although I did ponder the ability to automatically configure node configs, standardized but unique, which is along the lines of what Brian was mentioning, although it gets pretty clunky because every node has some unique settings, every node has some shared settings, every chain may have some unique tweaks.
That's assuming they're all running 5, right? If you're not running 5, then it's all different, like CPU effort and all that kind of stuff.
Yeah, I mean, from the BP side, and really even from all of my nodes, because those configs were in all nodes, they just didn't matter, except every damn one of them wouldn't start because it had CPU effort percent set in the parameters, even though it may not have been an active BP at the time. But that's when it was like, you know what? Trying to dictate how to get Minion to go and update, you know, it's like 140 nodes or something like that. It was like, all right, here's a new config. Use this across the board. And I actually did a pretty good job I don't know, Ross, if you looked at the spreadsheet, I've actually updated a default config parameters and for the different API, state history, and block producer. I can share it, Brian. I don't know how public it is.
I will look at it right now.
There's a few of y'all that probably have access to it, but my little pet project. Brian, I think you have. I mean, I'd be happy to share it. Minion doesn't exist. Oh, you don't need to see Minion. Just know he's the one that's rinsing, repeating the other 139 times.
I think I'm in there. This is the EOS config matrix, right?
Yeah. And then over there, there's a default config. And I don't know if all of them are perfect. I know one or two of them are more for mine, but I've really tried to kind of streamline.
Right.
Like even our peer-to-peer nodes run the API extra. So, yeah, see, Matthew's got 8 configs, something like that, for each chain, which he's on all the chains we are. 10 chains, 11 chains, plus test nets. There's about 24 chains probably.
Are you, Matthew, are these all like human managed in the sense of like deciding what the configs for each of these should be? Or are you like somehow generating these individual configs? How's that working?
This is human managed.
Okay.
Curated at the beginning and then mass deployed via scripting and logic. And
Yeah,
I was
exactly.
pondering it. I thought about you a lot this morning, and I was like, oh, I know why he does it and how he does it, but it's monstrous.
Yeah,
So that
it's all
means
stored
you've got-
in Git, and then when you deploy a node, it grabs it like this is a I don't know, peer node. So then it grabs the config for the peer node and
Correct.
deploys that with the thing, right? So you can't deploy a random type of machine. It needs one of the things that's
Right.
listed.
And that's, so you're managing something like 80 individual config files, is that?
107, it says.
107
Oh,
config
there it is.
files.
Yeah, I didn't, yeah.
That's config files. That's not even the number of nodes, you know, the whatever.
Yeah,
but
there's way more nodes, right? Because one config file is used for many nodes.
now
What did
I
the
did
update
notice
look like?
half of those are probably related to his peer-to-peer meshing, transaction only, relay only, things like that, which is hopefully somewhat less needed. But yeah, I mean, I've got 4 and actually a 5th one. I haven't done the snapshot node yet, but API, all nodes, you know, common settings, APIs, peer-to-peers, state history, and block producer.
Those are your individual configuration file sort of patterns, if you will.
Yeah, like I say, I've got a common pattern for all nodes, even though there may be some, you know, like my peer-to-peer nodes are probably running the API parameters just because I didn't want to have to. That's how you forget to turn shit on. So account queries is on all the peer-to-peer nodes, even though it's not needed, right? And then the extra API settings, max threads, stuff like that. I don't know. I mean, you can see in there.
Is there enough in common, Matthew, between your different config files where like being able to have a sort of default config and then overriding just certain settings would be?
I asked for that a long time ago.
Okay.
That we have a config.d directory with individual files, because then I could manage these as little chunks and then glue the pieces together, and then voila, then I don't have to repeat
that was the poor man's way.
Size parameter in each one of those EOS ones. I could write it once and then it would be deployed to each machine, right? Because there are common things between all EOS chains, and then there's common things between all say peer or API nodes across all the chains, right? So it's really a matrix, but I have to manage each file individually because I don't have a way to.
Yeah. I wonder if that's a candidate for like a leap util, Kevin. Like So rather
I
than.
mean, I could manually glue the files together, right?
Right,
But
right,
I was
Well, that's what I
hoping
was-
that config.d would come along at some point, but.
And what I'd almost kind of narrowed down is the groupings of, because that's what I'm a bash man. So, and we have an internal, I don't have to use Git. I've got internal, everything's a local network here. So we just got a web server where we keep all the binaries, all the standard configs, and he just pulls the scripts down.
Oh, you stopped compiling them on each machine.
I did. Now, I mean, I do random things. But anyway, all that being said, if you look on there, actually kind of towards the top, so it's like, the local directories. And of course, on my nodes, not all of the directory paths are identical. Some maybe local, OneDrive, some maybe on data drives or whatever. I need to fix that, but data 01 and data 02 burns me quite a bit. The different ports, because, it's the same API port for the same chain, but when I run multiple instances, so that gets very granular about what chain and what API port, because they all coexist to me. Then you get a bunch of the plugins, the API settings, stuff like that, the chain state DB size, which we went back and forth on, and all of that. So that's kind of all common, right? And then the peer list is separate. I mean, every set of nodes typically has its own set of peers. I'm curious, and I was going to ask Kevin and DM, what happens when a peer list has itself in there? Is it going to talk to itself? Is it going to ignore itself? Not localhost, its own IP.
Right. It should realize that and sever the connection.
Skip it. Cool. That's it. Not chew up any extra valuable peer-to-peer slots. So anyway, that's another file, right? So I need an agent name. That's another unique one that's on each individual box. That way, when it's phone and home, it's whatever. So you almost have a local settings for your box that are always unique. You have some chain specific or, template specific based off of the chain. You have different settings that are based off of the role, state history, API, block producer, things like that. And then you've got the peer list. And of course, depending on how your peering is, can be quite dynamic. Luckily, we peer all of our nodes internally and then use dedicated outbound.
I think that's a helpful sort of list of the different pieces of config. Let's run through that one more time, a little more slowly to make sure I knew it.
Go back and watch the recording. Look at the document, and the way I was rattling it off follows how I've grouped them and kind of whatever.
Okay,
so it'll make more sense. But yeah, I mean, the point is there are some things that are local to the node itself, unique, agent name being number one, right? Block path number two normally. There are chain specific settings. Ours tend to be like the API ports. And then some chains use overclocking, some chains don't. I mean, there's some variation, but there's chain specific. There's the global settings, which are pretty much, look, all of them. They all can support 150 peers, even though they may only have 5, and they'll never have more than 5, right? The individual plugins, which are state history, block producer, they've got their own tweaks and nodes. And then the peering list, which, like I say, it can really get unique. But worst case, because it's not as dumb as it used to be, at least a common peer list for the chain. I can't have Ross's EOS nodes trying to sync to my Telos nodes.
Yeah, but you can't have a common peer. Okay, so this is more complicated than this. Because
I don't disagree. That's why I said it's unique.
If you have two, say API nodes in the same network with the same peer list, most of the peers are not going to work because the number of remote connections allowed per IP address is set to 1 on the remote side, and then they won't connect. So really, you want half the list on one API and 1 on the other.
Unless you've got separate public IPs.
If you have separate public IPs, then you're good. But if you have
now you see why
behind that
peer-to-peer over to the side.
So so like Michael, we have a whole other process to manage the peers that's not in the configs.
Correct.
It's so funny that when we have these calls, we've all lived the same lives.
But we all solve them differently, so therefore there's no one good solution, because it's always like, no, hell no, that's not how I do it. Although how you do it is effective, right? So that's why I say peer-to-peer, all the configs and the parameters and cleaning up, all that's, whatever. But the peers almost are unique based off of everybody. I mean, it needs to be local or close to you. You don't need to peer with the kangaroos. It's really slow, I can tell you.
I tell you what, often a place I start is the EOS Nation validator, just to get a peer list of peers that are live, right?
I can tell you this though, what I ran into when I started doing that is I was like, okay, fine, just start all these valid ones, just make sure I don't lose sync, because we all know EOS USA loves to go into comas, right?
Yeah.
I started using hundreds and hundreds of megabits worth of useless traffic because I was syncing the same blocks from the same peers to the same nodes sitting in the rack side by side. So I have streamlined all of my internal nodes, talk to dedicated peer-to-peer nodes. That also helps with the whole filtration of subjective billing and all of that. And then I use for my peer-to-peer stack, the nations validator. I actually take them and split them up evenly between all the different nodes. But so it's a whole nother rabbit hole to go down. What I will say, and we've talked about it many times, and this may be where Matthew's going, the automatic peer discovery and peer management, and if it would take care a lot of the default logic, it's getting better about not being stupid, but it's still a little ignorant. But that would help address a lot of the whole peer-to-peer management. So that's kind of why it's at the bottom of my list. It's so dynamic. Everybody's different. It needs to be different, right? My block producers technically need to be peered completely different than my API nodes, right?
Yeah, I mean, just to add, so I agree with that. It's complicated. To add, our initial setup, you remember Ghostbusters?
Mm-hmm.
Way back at the beginning, right? Ghostbusters said use WireGuard to connect. Guess what? We have WireGuard for everything, because that's how that's all set up. So in fact, all of our internal nodes all connect to each other with WireGuard, because everything was set up with WireGuard, because we were running over the internet at the time, because we just had a bunch of DigitalOcean droplets which didn't have a common LAN between them, so everything had to run over the internet. So anyway, so everything got WireGuard together. So now that we have our own data center, guess what? The WireGuard thing persists. Because, so all the internal nodes are all connected with WireGuard as well as external, when needed.
Enlighten me on what or who Ghostbusters is. I only know
the legend of Ghostbusters. I don't know who started this. Sweden?
I think it was
they
Sweden.
were part of
At the beginning of
EO.
EOS launch, there was like two groups, kind of like one wanted to use WireGuard for security and one doesn't. And initially with this whole Ghostbusters, I remember we used also WireGuard, which in essence you're creating it's kind of like a VPN,
Private
but
network.
you're creating your own LAN, like your virtual LAN. And does it, helps with the firewall. Basically, you can only mesh with each other, you can connect to each other, and so on and so forth, versus just opening a direct port and giving the IP address. But I guess at some point it was like kind of became redundant. It's not as needed. You could achieve the same, advantages without adding that complexity. And I think most people dropped it, but apparently not.
It still exists. A certain Antelope or Antelope-like chains require it to peer.
Yes,
Some people still use it on Wax or EOS. It's still used in some cases for private.
It's a novel concept. It just adds a lot of layer of complexity that I personally don't.
It's fine. We don't have to discuss it here, but I just wanted to add it to the complexity list.
I appreciate that.
And we also set up private keys for all the peers too. So each node has a private key. There's private keys between nodes. There's WireGuard, and then there's all this config. So like our config is like Michael plus in terms of complexity. So obviously there's a whole bunch of automation to make all that work.
WireGuard was using the private keys too, right? Like that was the idea. Like with WireGuard, is you're still securing it through encryption by providing your own keys that you need to share with others.
Yeah,
and I think as EOS added it into their support in Node EOS, where you can do kind of similar things.
Correct. So we have both.
I don't think you're getting additional value other than you might be still forced to do it.
Yeah,
anything,
probably not. But what it does prevent is, for example, if we reuse an IP address in our network and something was peered to it, but then an IP address is used for something else now, it doesn't have the private key, so now it won't connect. So it prevents, weird connections from happening within the network.
Yeah, duplicate IPs in your network,
that was
but at least the security won't
save a lot of stuff for Michael, that one.
Yeah, it's not duplicate IPs, but it's like, we got rid of one node. That IP address is free now, so now it gets assigned to another node, but that node has a different purpose, and we don't want it.
It's different layer 2 solutions. I mean, like I say, and the answer to Brian's question was originally the documentation of EOS was very, very lacking, and there kind of came two methodologies. One was the just get her out there and get her done, and then Ghostbusters had a much more security-minded, layered approach. APIs separate from BPs, separate from, whatever. It was that initial concept that kind of transformed into the morph of what we have today. It was interesting. Anyway, you had asked how 5.0 was going, but it led to the discussion about the configs and the standardization. But
on that topic with the upgrade to 5.0, I'm curious, Matthew, with 107 configs, how was the experience updating for 5.0 across all of that?
Well, I'm not sure if that's a fair question, because we did a lot of testing prior to the 5.0 launch.
Sure.
So for us, it was like, oh, 5.0 is ready. Great. The only node we need to change the config on is the BP node, because we had already done the configs on all the other things during the test phase, because those were already upgraded with it using release candidate 2 or 3 or 3+ or whatever. But in general, the answer was fairly straightforward. So once you know what configs you need to change, then we just did a mass edit on all the files, search for this, replace with that, recommit to Git,
the changes that were required, you were able to do a mass effort edit. If we did have some kind of like default config override system type of thing, you would have just changed it in just the default, or would you still have had to edit for each chain? Or for each node type?
Well, so if we're gonna do some default thing, then I'm gonna need to do versioning on that file, right? Because here's the default for peers for 4.0. Here's the default for peers for 5.0. And so then I would need to tag which kind of version is on which node, so then it pulls the right one. Because we can't upgrade every single node all at once, right? Or especially, some, networks are still on 4.0 or 3.2. They don't have an Antelope 5.0 compatible.
I would say if you're going to have either leaputil or Node OS or something like that, maybe generate some type of default config, the version that it is, if you're running 4.0, fine, generate it off of 4.0. If you're running 5.0, here's your 5.0 version, just like it is right now, where it prints the default config based off of whatever version it is. Then it's up to the nerd herd to decide how they want to use that. But yes, it is, like I say, it's very dynamic and unique. I would say the reason there weren't a lot of extra changes in the configs, there were a lot related to the BP. That was really what triggered it. To me personally, it was a lot of 3.0 change shit, 4.0 change shit, 5.0 change shit. Half of my config was commented out. And the other half is I'm not sure if that's even the right setting anymore. It's like that because of a reason, but my limit for the HTTP track timeout is through the roof. Now that's because people ran into issues at the HTTP
I still need to revisit that config. It still has a comment next to it saying GitHub issue, please check. So
that's why, and I think a lot of us fell into that same, and it's only old dogs that were more, look, flush out all the old way of doing it. Let's try to restart. The defaults are a lot better, not the resource monitor. But so get rid of the overrides and go back to just letting the defaults.
Well, that almost went past me there.
I thought you got that.
All right, let's change topic away from configs for a moment. So I want to go back to Seth pointed out a memory increase. So I want to, for the purposes of this conversation, disambiguate between system memory and RAM, where RAM, of course, is EOS resource, and system memory is, sort of your, what you would see in monitoring a particular node. So we made some changes that we anticipated would make Leap 5.0 more efficient with system memory, at least in terms of state data in memory locally, right? What we have heard some reports of, the RAM increase. I am curious whether that has translated to system memory increases overall, or not, right?
Are you referencing the issue that I had where it was rapidly increasing memory?
Well, so that, yeah, so a few weeks ago, Michael pointed out a rapid increase in memory that we looked into sort of last minute, and were able to confirm that there was I wouldn't call it a memory leak, but like for all intents and purposes, let's call it a memory leak for this. And we were able to fix that thanks to the heroics of Matt Witherspoon. So he got
that was awesome. Like, because the report came in on the operator call, and the release went out on the Thursday, one day later, and the issue was fixed. So
that's when Brian sent me a message. He was like, "Hey, we got it fixed," and I'm like, "I'll be the judge of that." But that's why I asked that question. From all intents of what I can see, yes, it's much. It looks the same as what it was before. I'll say on the test nets. That's where it's mostly. So I wouldn't say it dramatically increased, its efficiency from what I see, but it definitely was not growing like it was, and seems much more stable. So
yeah, so the and then from a system memory perspective, state memory, of course, is only one component of the memory usage of Node EOS. However, I would anticipate that it's one of the larger sort of components of memory consumption by Node EOS. So what we would have anticipated is, all things being equal, that memory utilization would have gone down. That said, not all things are not necessarily equal, because of course it's running on production networks that can continue to increase state memory size, right? So all of that said, yeah, I'm just curious about like if there's been any kind of observations around local system memory consumption by Leap 5.0 sort of after 5.0 stable release.
Best I can tell, my EOS APIs are the same memory and usage. So not as, leaking or going up, but I'd say almost right on with the benchmark of 90 days. So it ran for 60 days, like flat. And now it's back to running that same level of flat at the same capacity.
I'm curious, Kevin, how that jives with what you would have expected.
Sorry, Ross.
In terms of the memory usage, I mean, we've had a lot of RAM growth on EOS mainnet.
Right.
So
yeah. So
I don't see that, and I'm in map mode, which we had a big long discussion about how that works and what it does. I have seen an increase in traffic from those nodes, like instead of 10 megabit,
so again,
20.
disambiguation here, right? System memory versus RAM, like network resource. So I think,
Correct.
correct me if I'm wrong, Kevin, but I think what you're saying is the network resource RAM usage has gone up, but I'm kind of piecing together different pieces of information here. But Michael's saying the system memory usage is somewhat flat compared to previously. So it may be that we are seeing a reduction in memory utilization, but it's offset by network RAM usage. Is that like the state data itself?
I think the state itself went from like 33 to 37.
Right.
And the shared the map I think it's called map private now. The method I didn't look into it much, but from what I kind of just gathered, checking like ls on a few files, is you're just keeping it all in memory, handling all the state in memory, and when you close it flushes. So in effect, you'll have slower, when you're closing, it might be slower depending on your NVMEs or whatever, but it's faster because it's all running in memory. And then what gets allocated to the process is based on what you put in your chain DB config, as in like that's the maximum that will be reserved for that.
Right.
But as others said, I haven't seen any like, obviously I'm testing only the stable version. I haven't seen any memory leak outside. So like my understanding is it's just the RAM is being used more on chain, which is just par for the course.
For context, the changes we made were that the underlying data structures of how we store state data in memory were sort of overhauled to be more efficient. So the same amount of
RAM,
the same amount of RAM should take less system memory than before. No, let me put that a different way.
You can store more data in the same RAM usage.
Yeah, exactly. But it does make sense that if we have an increase in the system, in the network resource, it would offset efficiency increases on the system memory. So, okay, let's just keep an eye on that. I am curious, like, as we have more data of it in production, how increases in the RAM network resource compared against local system memory. What's the word I'm looking for? Compares when normalized against prior data, but we can move on from that.
I just want to ask a question, since we were talking about this topic, about producer threads. I remember in one call, Kevin mentioned that like now the new one, producer threads actually does will give you a small boost in production, having producer threads. I just want to know, is there a certain number of cores that, because depending on what is multitasking, is there a certain number of cores after which there is no additional value? Because in like the system generally, if you have an i9 or something, you're going to have, even if you overclock it, you're only going to be available to overclock, say, the first half of the processors to the maximum, and then the other half is going to be, so you might have to use CPU affinity, task set, or whatever to set the right cores that you want. So I want to get an idea of like, is more than 4 producer threads potentially giving any advantages?
So, I mean, yeah, obviously there's a limit to more cores, it being able to utilize those, because of what's possible.
What can be parallelized?
Yeah, what can be parallelized and just what is possible because of the other bottlenecks that are in play. So I will tell you now, this this is not real life, because this is us pushing the software to its absolute max, doing 40,000 transactions a second sort of thing. Well, nobody's doing that anywhere. As a matter of fact, it's not possible on any of the public networks, because it's artificially, or that's the wrong word, they're configured not to go that high. You can push as many
On-chain
transactions
limits.
as you want, and they're currently limited to 4,995 according to the on-chain consensus parameters. That's what it is. Like, you can't go any faster than that because right now there's a minimum number of transactions. There's a minimal billing amount for a transaction, and there's a maximum that's allowed CPU in a block. You do the math, and it's 4,995. Why is it not equal to like exactly 5,000? Well, the on block goes.
I think some chains have bumped that to 250 and maybe higher, just so you know. But
Oh,
yes,
okay. Well, then on
there's
those chains, then it would be a bit, well, if minimum's higher, then it's actually lower. They made it where you can't even do that many. If they've lowered the minimum transaction size to 0, then that gets you more. I don't know of any chains that done that.
They increased the block time, so they went to
Yeah, you can
250.
Right, you can increase the block CPU allowed to 250, and then that gets you whatever that would be.
20% more. Doesn't matter, but the point,
Yeah, a little
that's
bit-
the
a little
beauty
bit
of the
more.
product that
But-
y'all released. You can
But
tweak it to your
again,
own.
nowhere near like what we pushed it to of like 40,000 transactions a second.
That was
So-
me and Ross.
And there we found that the ideal producer thread was 6. We actually in our test harness, one of the things you can do is you can tell it to run, and you can say, find me the optimum thread configuration, and it'll run like it does this like an hour on run at 2, and then it tries 3, and then it tries 4. Well, anyway, we did that, and the optimal was 6 for flat out as fast as
40,000.
So there's no reason, obviously, to ever go above 6. So that gives you kind of the max number. Like it wouldn't make any difference. And I would say, probably 4 is more than enough on any chains that are out there running. What the producer threads are used for is during validating a block. It's used to multi-thread all the signature validation of all the transactions in the block. So it's that's where it kind of comes into play. It's also used during speculative execution as well. But I feel, I haven't verified this, but I feel that the big boost is the fact that like you get a block, you want to like immediately consume it as fast as you can, and it'll use all those threads to multi-thread those.
Right, and the more filled the block is, and
Right.
the bunch of blocks being filled, that's when you really see the benefits. So in our use case, with in addition to the limits and non-ideal, 4 should be way more than enough at least.
Right. And of course, when we're doing these, what's the fastest we can go? They're just EOS.io token transfers. So there's not much work there to be done outside of validating the signature. A little bit of DB stuff, but not compared to. Certainly not compared to like an EVM transaction, So, the overhead is completely flipped on normal transactions on the network, right? I mean, the signature validation is going to be some small fraction of the actual runtime of the transaction, as opposed to the toy ones.
And thus the effect will be even less. Right.
Yeah, even less. So,
Well,
I would say 6 is the absolute max. There's no reason to ever do more than 6 producer threads. And probably 4 on a normal chain.
It's already over.
Yeah.
It's already.
But again, like you could set that. They're just the overhead of extra numbers there isn't much. Like it'll just spawn up a thread during startup, and that thread may set mainly idle. But there's not a huge amount of overhead for just an extra thread setting their idles. So.
Right, it's like having a chain thread, it's like having the combination of net threads, chain threads, producer threads be more than your total threads doesn't matter, because if your chain thread is not using more than 2 or they're sitting idle, you're not losing much in.
Yeah, I mean, you look at any given time, your OS is running, maybe 1,000 threads from all your different processes and all the threads that they spin up, and so it's just going to like. If they're not active, they're not active. So, it really just kind of gives you the more of a ratio of tuning capabilities,
and the ratio, assuming they're all firing at full capacity, right? Because the ratio is only relevant if like you're gonna the core, all of the core can be used for that one process. Yeah. Otherwise, it's even less.
Now, one of the things that would be interesting for you guys to test, it's very difficult for us to kind of test in our testing, is in 5.0, the number of chain threads you give it should make a bigger difference. There were some bottlenecks there in terms of like concurrency. Some of those bottlenecks have been removed. So I've noticed I've noticed that.
So is this related to the producer machine or different types?
Any machine that's like,
Okay.
particularly your relay nodes that are handling, you know, your 200 connections, like those, they should be able to handle.
So peers.
Yeah,
peers, right?
peers,
Talking
right?
about
Peers.
peers.
P2P peers, yeah. The net threads, adding more there should make a bigger difference in a fight.
That's
Net
very
thread or
interesting.
chain thread? Which one? Because there's both.
Net
And
threads.
I don't know which one's which.
Net threads, net threads. We
I'm
actually
also-
moved
Chain
threads.
threads is the chain is the API, net is the peers.
Chain we don't actually even use anymore. Matter of fact, we removed it. I guess that wasn't 5. It's in 6.0. I think in 5.0 it's still, that setting's there, but it's ignored. I'd have to go look at that again, but it's
So
so
just push that out of
your
my new
configuration
config,
settings
right?
today in 5.0 node that you want to care about is your net threads and your producer threads.
So I'm
Net and
curious,
producer.
Perfect, thanks.
on the question of threads, and you talked about the signature validation. What plugin is it that handles the validation of blocks or whatever during replays? Would producer threads or any threads help the replay? I can tell you it took about an hour to replay 2 days on Wax blockchain. So I mean, it's
It depends
brutally slow.
on if you mean replay or sync into a network.
Replay. I mean, the
replaying a
peer-to-peer,
block log.
well, I don't know. I mean, maybe they're the same. That's why I asked. I don't know. Is that the
So
net?
if you're replaying a block log, so if you have a local block log and you're replaying it, we don't do signature validation on transactions in that process unless you explicitly ask it to. If you're syncing from a network, it does. So if you're syncing,
And that would be the
from a
producer
network,
plugin,
the
right?
producer threads will make a difference. If you're replaying a blockchain, it'll make no difference at all.
Interesting. So
So even if I'm
increasing the
syncing a
producer.
new,
Right.
yeah, so if I'm thinking, let's say like I'm behind a week, for example, in a node,
Yep.
and I want to catch up, even though that's not a producer machine, it's going to use the producer thread.
It does, yes.
Okay, got it.
It's a bit like we've named things, like naming's hard. So
Oh, yeah.
that's why like the producer plugin is always active. Like you can't.
That's why I asked that.
Yeah,
Is that
you
I knew
can't
y'all had
disable it.
started
You
throwing
can't-
them.
It's there whether you want it or not. And so what makes you a producer in the terms of like a BP, like maybe BP is the better term for here, is that because a non-BP node produces speculative blocks. So the producer plugin produces speculative blocks. It only produces real blocks if it's configured to be, you know, if it has a signature provider effectively.
Does that
well,
mean-
the producer name, right? What you have to.
Yeah, correct. Producer name
producer
and signature
name and
provider,
signature
those
provider.
two.
Yeah.
I'm curious, when you say that, because of the speculative block production, would an API, at least that's maybe under heavy burden, have benefit from extra producer threads?
Yes, all
and
nodes
even
would.
your peer-to-peer relays that
all nodes
are-
will, because you want to, when you receive a block, you want to process that block very quickly, because you want to get back to whatever else you're doing, right? If you're API node, you want to get back to processing the API request.
Correct, but that producer plugins
So
and
every
threading.
node has to receive blocks. When it receives those blocks, it has to process them. Having those threads to do the do the concurrent signature validation on the transactions in that block is useful.
Which is the first step, because now it's all like block delivery is the most prioritized, you know, like
yes,
job of Node EOS. So really, it's your producer thread is going to be the initial potential bottleneck if you don't have enough cores and you sync with a lot of people.
Matthew makes an interesting point here. Should we be setting a default producer thread value in the future, like 4, for example?
The defaults on all of them. Well, I'm sorry,
Right.
we just changed net threads. We changed net, I think, to 4. The default for the other 2 are 2. Again, the chain one is ignored. But yeah, I mean, it's like, what do you use for a default, right? Because if somebody's running a local Node EOS on their laptop to do testing, well, you know, I mean, those inactive threads probably don't mean much overheads, but
Yeah,
we
I mean,
pretty
that's
much
the
use
thought,
4.
is the-
To answer your question, we've used 4 threads, and then on our API nodes, it's 8 or 12 if they're
I
getting a
mean,
boost.
with what we've learned, like it probably does make sense to increase producer threads to default to 4 now. It was 2 in the past because back when I worked for a different company, we did a bunch of performance testing, and we found that like it didn't make any difference, the producer thread count. You would go to 2 to 4, it made no difference on performance. And so
that's likely due to some of the bottlenecks
we've removed bottlenecks. Like we're always enhancing performance, or we're trying to, and we've moved some performance. And I mentioned, like I was talking about the net threads, increasing that should help. And you guys can tell that better than we can. What I have noticed is that we fixed some bugs that are due to higher concurrency, which we didn't have, that don't show up in 4.0, which tells me that 5.0 net plugin is actually getting better concurrency than in previous versions, because like we never saw these issues before, and all we did was like make it more optimal in its ability to run multiple threads at once. So that tells me we're getting better concurrent execution.
So speaking of CPU stuff, a couple of interesting dynamics in 5.0 is that, pursuant to the conversation we just had, we did a lot of improvements with concurrency, like getting things off the main thread, allowing, removing bottlenecks to allow more threads, et cetera, et cetera. We also, made some changes to when ESV MOC is applied, which we've discussed on this call before, which just means that for certain contracts, namely system contracts,
it'll be on by default, like the auto will mean on for these ones.
Which means that the amount of CPU utilized for those for actions in those contracts would be less. So there's dynamics here are that there would be lower CPU utilization for certain things, like meaning to do the same work takes less CPU processing time. But also with the increase in concurrency, it's Node.EOS is capable of consuming more CPU simultaneously, right? We did see a report, I should say, of a subtle increase in CPU after upgrade to 5.0, which at first had me scratching my head, because I was like, wait, we improved that. I don't understand why that happened. And then thinking about the fact that we've got all this threading and stuff, it kind of started to make sense. Anyway, what I'm bringing this up as just hey, let's keep our eye on CPU utilization as well, so that we can get more data there in production. I have a couple.
We use like 15% average CPU on our nodes.
Say that again.
Like I think we use like not more than 15%,
right,
or so of CPU running in production.
Yep. The upshot of all of this, hopefully, is that one, we could theoretically handle more transaction throughput in the future, and two, if there's not higher transaction throughput like in production, then you could theoretically run more nodes on less hardware, right? So yeah, those two things.
Well, I was quite interested in what Kevin said about manipulating the number of net threads, because on WAX public peers, where we've got like 200 peers on multiple nodes, those things have got, I think, 8 cores, and that's running at 70%, like across all of it. It's so busy. And that's why I'm thinking, oh, that's interesting. Maybe if we give it more cores, give it more threads or whatever, And of
Yeah,
course,
I mean,
sorry,
if it
and of
only
course
has
that is
8 cores,
404, right?
right, yeah, potentially that, I would kind of expect that it could, with that many number of connections, I would expect it to be able to use a few more cores.
Yeah.
Be interesting
Does a producer, so does a producer thread help? Like if you have more peers and you're getting the same block from multiple peers, is it validating each one, or it will just like
Well,
it doesn't help there?
no, it'll only validate the one for any given block. Now, if you get like some unlinkable, it'll when it tries to like figure. So occasionally you'll get a block, but
that never
very
happens.
rarely, unless you're EOS USA, and then for whatever reason. But no, it dedupes blocks, so you only ever evaluate one block at a time.
So the only thing is really net threads that could improve the performance in that.
For a peer, like what Ross was talking about with like 200.
Yeah, I'm interested because I mean that'll be a good test for me, because that's just straight into the fire. That's the busiest nodes. I think they're doing a constant 200 megabytes of data across the multiple nodes where they aggregate. It's just there's so much going on there, and those things are thumping. So when I go to 5, it'll be like, here's the litmus test.
Yeah,
what happens?
I would be really curious for you to tell us how that goes, whether you noticed anything or not. I mean, who knows? Those sorts of things, in practice, sometimes they don't turn out as as well as you hope. But
yeah.
My P2P nodes aren't anywhere close to that level of CPU utilization. I mean,
We are, I imagine for API nodes that, like public API nodes, that's an interesting.
We've got 100, 150. I mean, maybe not quite as many as Ross, but I mean, we take there ain't too many EOS nodes out there. So
they've got gigabit internet connections as well, right? So
yeah, I mean,
it'll rip the 2 gig, and so there's like it's ripping. It's constantly just giving stuff.
But Ross, you were talking about
average
wax,
about 200
not
megabit.
Right.
I average about
wax. Yeah. The other ones are nothing else is anywhere like wax.
Yeah. The traffic on wax is, order of magnitude larger. Well, not that large, but I mean, it's double EOS for sure.
Or more. For me,
yeah, or more. Yeah. Depends on the day. Recently, we've had some good traffic on EOS, but before recent, it's as much as 6x EOS. Just looking at like blocktivity, the number of transactions.
We are running up on time. We did not get to the sort of brainstorm on non-producer nodes. I'm going to save that topic for next week's agenda.
Well, we kind of got into it because all this
stuff
is related to that anyway.
Yep, but I do think some focused discussion there will be worthwhile. I guess my call to action here for this conversation is just, hey, keep any kind of, if you observe anything interesting with regards to memory utilization, CPU utilization, or really anything else sort of post 5.0 upgrade, please feel free to report an issue, even if it's not necessarily a bug. And of course, we can sort of just gossip about these things on the Antelope Node Operators Roundtable channel as well. So that's what I have. But thank you everybody for engaging in conversation. I picked up several really interesting notes and a couple of possible suggestions for improvement in the future. So really appreciate that. And we have our a topic for next week, unless something else more pressing comes up. But I'll see everyone next week.